The next step is to set up the math. So we're going to choose a xy coordinate. We see these blocks are moving to the right. This one is going to move down. So it is normal to choose the right one as x and the vertical one as y. Then we can write out the net force on each direction. Let's start with the x component. The forces that is in the x direction acting on M1 is just the purple one, which is the friction. So for M1, the x net force will be the friction, and that's it. For the y direction, it's going to have a gravity pointing downward and a normal force going going upward. So for M1, the net force it get in the y component is going to be the normal force and the gravity. Because gravity is pointing downward, and we choose upward as the positive y direction. So here the force goes downward will give us a negative component. So gravity will be negative when added into a net force. This is what the y component of the net force on M1 looks like. For M2, the x component has two contributions. There is going to be the tension force given by the string and the friction force by M1. So M2 is going to have a tension in the x direction, and it is exerted by the string. And again, because we use right as a positive x direction, so the friction on M2, which is pointing to the left, will be negative for the x component. Therefore, we have to subtract the friction that is acting on M2 by M1. Now, the y component of forces will have a normal force by table, normal force by M1, and gravity. The normal force by the table is pointing upward, so it is positive. This is acting on M2, I'm sorry. So the normal force is upward, therefore we choose it to be positive by the table. And because the normal force from M1 is going down, so we have to subtract it by M1. And the gravity is also pointing downward, so it will also be negative. The gravity on M2. So these are all the y component of net force. Finally, we have the forces on M3. The net force it get in the x direction should be 0 because there is no force acting on M3 in the x direction. So we see the net force in the x direction is just 0. When we look at the net force in the y direction, we see there's a tension going up, which we take as positive. And then there's going to be gravity going down, so it will be negative according to our convention. We have to subtract gravity on M3. So these are all the equations we can list to get the net force on these three boxes.